Hello and welcome. Look, if you're building with large language models, you know those API bills can be absolutely brutal. But what if I told you there was a powerful, almost shockingly simple strategy to slash those costs? We're going to dive right in because today we are unpacking the single highest return optimization you can make to your production LLM systems. So let me just start with a provocative question. What if the vast majority of your AI spend was just pure waste? Seriously. What if you were paying over and over and over again for your model to reread the exact same page of a book 1,000 times a day? Because that is the core problem we're going to solve today. So here's our game plan. First, we're going to diagnose the problem, something I call the redundancy tax. Then we'll get into the solution, token arbitrage. We'll see it in action with a crazy 90% cost reduction case study. But we'll also talk about its main limitation, the 5-minute wall. And then discover how this whole thing enables you to build smarter AI. And of course, I'll leave you with a playbook to get this right. All right, let's start with the problem itself. There is a hidden cost, kind of baked into almost every single API call you make, and it's called the redundancy tax. Just think about your prompts for a second. They're not just the user's question, right? No. They are loaded up with huge chunks of repetitive information. Long system personas, instructions, tool definitions, or those few-shot examples that tell your AI how to behave. And the thing is, this data hardly ever changes from one call to the next. And this slide, this just breaks down the anatomy of a prompt perfectly. On the left, you've got the static prefix. That's your asset, the huge, unchanging block of context. But on the right, you have the tiny little dynamic suffix. That's the user's unique query. Without a smart strategy, you are paying to reprocess that entire static asset every single time.
And that's what we're officially calling the redundancy tax. It is the price you pay for forcing the LLM to recompute the attention states for data it has literally seen 1,000,000 times before. It's a crazy inefficiency that can account for up to 95% of your total token spend. No joke.
So the big question is, how do we stop paying this tax? Well, the solution is to turn that cost into an asset. And this is a concept called token arbitrage. The economics here are, well, they're fascinating. Take a look at this table. Normally, you pay a base input rate, let's say $3 per million tokens. With prompt caching, the first time you send that static data, you pay a small 25% premium to write it to a temporary cache. Okay, but every single time you access it after that, you pay just 30 cents. A staggering 90% discount to read from that cache. You know what the most incredible part is? The break-even point is basically immediate. In the real world, this means you start saving money on the second call. This isn't some complex, niche optimization for edge cases. This is a default requirement for almost any stateful conversation you're building. Siri is great, but let's see what this actually looks like in the real world. This case study shows just how absolutely dramatic the savings can be. Okay, so imagine a bot. It's designed to answer questions about YouTube analytics. To be accurate, it needs the full context of a channel's metadata, and in this case, that's a massive 81,000 token JSON file that gets sent along with every single user question. So, without caching, every single user query forces the model to reread that entire file. The results? A monthly bill of $732 for one bot instance. Now just imagine trying to scale that to 1,000 users. It becomes prohibitively expensive, fast. Okay, now let's apply our caching strategy. We pay that small write premium one time, and then we get to enjoy that sweet 90% discount on all the requests that follow within a session. The new monthly bill? Just over $80. I mean, the difference is staggering. Look at that chart. It's not a small optimization. It is an order of magnitude shift in the entire unit economics of your product. That's over $650 saved per month, completely transforming the business case overnight. Okay, I know this sounds amazing, but it is not a magic bullet. To use it effectively, you have to understand its primary constraint. And this is what I call the 5-minute wall. See, the cache isn't permanent. It has a time to live, or TTL. So the first request starts a 5-minute clock. Every time you get a cache hit within that window, boom, the clock resets. But if there's a 5-minute gap between requests, poof, the cache just evaporates. And this is the most important warning I can give you. If your requests are consistently more than 5 minutes apart, you will never get the rediscount. You'll just keep paying that 25% write premium over and over again, which means you're actually increasing your costs.
So this strategy is perfect for interactive chat sessions, not so much for, say, a cron job that runs every 10 minutes.
So what do we do with all these savings? This is where it gets really exciting. Prompt caching isn't just some cost-cutting trick. It's a strategic enabler that lets you build fundamentally more powerful AI systems. We can now think in terms of a hybrid architecture, kind of like the System 1 and System 2 model of how our brains work. We use the cache for System 1. That's the fast, automatic recall of our massive static context. And this frees up our budget for System 2, the slow, expensive, and deliberate reasoning that happens with the user's unique query. This is really the key takeaway. We stop thinking about tokens as a constraint, and we start seeing them as a lever. The money you save on caching all that context can be reinvested into more complex reasoning, more few-shot examples, or even just using a more powerful, more expensive model. All right, you're probably ready to go implement this, so let's wrap up with a quick playbook, focusing on the subtle traps you absolutely positively need to avoid. You gotta understand, the cache key requires an exact bit-for-bit match. This leads to what I call cache-busting traps. An extra space at the end of a prompt, the space bar killer will break it. If your code generates a JSON object but the key order changes between calls, that's a different cache key, no hit for you. You also have to update your monitoring to specifically track cache hits and misses. A sudden drop in your hit rate is a critical production alert. So I'm gonna leave you with a question that really reframes this entire discussion. Is your prompt's context just a disposable commodity you burn through on every call, or is it a reusable, high-value asset? The answer to that question could save you 90% on your next AI bill.